You ever have one of those days where you just feel off? Like your energy, your mood, even when you get hungry, it's all running on a schedule you don't control. Well, that's because it is. Deep inside all of us, there's this powerful, invisible clock ticking away. And today, we're going to dive into the inner workings of that body clock.
So, let's just get right to it. What really happens when you sleep? I mean, it feels so passive, right? Like you're just hitting the off switch on your brain for a few hours. But the reality? Oh, it's a whirlwind of incredibly complex activity. This isn't just about feeling rested. This is a journey deep inside your cells, touching everything from your genes to your brain chemistry.
First up, we've got to talk about the body's hidden clock. And trust me, this is about so much more than just feeling a little groggy in the morning. Let's forget all the sleep hygiene tips for a minute. Don't look at your phone, all that stuff. We're going way deeper to look at the actual biological machinery that runs the whole show.
Okay, so at the very heart of all this is one simple, amazing fact. Your body operates on a roughly 24-hour internal master clock. And this isn't just a suggestion, it's a fundamental rhythm that's literally built into you. It governs your energy, your mood, your metabolism, pretty much everything. Think of it as the conductor of your body's entire orchestra. So, if there's a conductor, where does it get the sheet music? Well, it all starts with your genetic sleep code. You can think of it as the master blueprint for your day written directly into your DNA.
Now, the scientific term for this blueprint in action, that's the circadian rhythm. It's simply the natural internal process that regulates your sleep-wake cycle, and it repeats itself, you guessed it, roughly every 24 hours. This is the master program we're really digging into today.
And if the circadian rhythm is the clock, then these genes are the gears that make it tick. Now, don't worry about memorizing the names, that's not the point. Just think of them as a team of tiny molecular workers. Some of them, like PER2 and PER3, they build up during the day to help make you sleepy. Others act like brakes to make sure the cycle doesn't get out of whack. They are your body's personal microscopic timekeepers.
And just like with any finely tuned machine, if those gears get rusty or out of sync, the whole system starts to have problems. When there are variations or disruptions in this genetic code, it can lead directly to what we call circadian rhythm sleep-wake disorders. The really crucial point here is that the root cause can be written right into our cells. But genes are only part of the story, right? They need to communicate with the rest of the body. And that brings us to our next layer, metabolism. This is all about how your body's energy systems are constantly talking to that genetic clock, telling it when to speed up or when to slow down. And this just shows you how deep that connection goes. It's pretty wild. Scientists can literally find the chemical evidence of sleep problems in your blood. They've found that the levels of certain metabolic byproducts, think of them as the chemical exhaust from your body's engine, are totally different in people with chronic insomnia. Your blood chemistry can actually tell the story of how you sleep.
And it's not just energy byproducts, it's fats or lipids too. And what researchers have found is just fascinating. Some types of lipids seem to actually protect our internal clock, while others are straight-up risk factors. So you can see on the left, one type of lipid seems to be protective, but over on the right, other types are linked to a higher risk of issues like sleep apnea. It's this constant chemical balancing act happening inside you all the time.
Okay, so we've covered the genetic blueprint and the metabolic fuel. Now let's go to the command and control center, the brain, and the very specific chemicals it uses to manage this whole process of being asleep and being awake. Let's start with a key player you've probably never heard of, neuroglobin. And the absolute best way to think about it is like a rechargeable battery for your brain cells. It's found in the parts of the brain that regulate sleep, and its whole job is to keep that system in balance, a process called sleep homeostasis. And this chart shows you exactly what that means in practice. When your brain is rested, your neuroglobin levels, your battery charge, are nice and high. But after you've been sleep deprived, boom, those levels drop significantly. This is a perfect visual for why sleep feels so restorative. You are literally recharging your brain's cellular batteries. Beyond just chemicals, scientists can also measure sleep quality electrically. By looking at brain waves, they can actually see that specific patterns, like delta and theta waves, are the hallmarks of deep, restorative rest. It's just another amazing window into the mechanics of how our brain recovers every single night. And this brings us to our final, and maybe the most critical point of all. What happens when this finely tuned clock fails over the long term? Well, the scientific evidence is pointing to a serious and direct link between a disrupted body clock and the risk of neurodegenerative diseases.
So this quote from the research really sums it up perfectly. There is a bidirectional relationship between sleep regulation and brain health. What does that mean? It means it's a two-way street. Poor sleep harms your brain, and a harmed brain leads to even worse sleep. It becomes this really dangerous feedback loop.
And this isn't just a theory. We have concrete chilling examples. A rare sleep disorder where people physically act out their dreams. It can actually be an early warning sign for brain diseases like Parkinson's. And the really crucial part? The sleep problem can show up years before any other symptoms appear. That just shows you how fundamental sleep is to brain health.
This slide maps out that vicious cycle we were just talking about. It starts with a circadian rhythm getting disrupted. That leads to an increase in what's called neuroinflammation. Over time, this contributes to brain cell loss, which in turn makes the neurodegeneration worse. It's a devastating domino effect, and it all starts with a broken clock.
And that really brings us to the main takeaway of this entire explainer. Regulating your sleep and your circadian rhythm isn't just about what happens when your head hits the pillow. It is a constant, active, 24/7 process that is absolutely essential to your overall long-term health.
So I'll just leave you with this. If your sleep is basically a daily report card on your deep cellular health, from your genes all the way up to your brain, what is your report card telling you?
Thanks for tuning in.